Our universe is a very dynamic place that puts on spectacular cosmic displays every second. With Roman's panoramic vision, we'll not only catch these events, but we'll see many at once. And use this to uncover the distribution of dark matter in our universe. Most of the sky remains to be explored. We're likely to not confirm current models, but to get to explore entirely new phenomena for the first time. I think when you build an observatory that has profoundly new capabilities, the most exciting science is going to be the thing that you didn't expect.
Good morning. I'm Leah Martin with NASA Communications. Thank you so much for joining us for the pre-launch briefing as we anticipate the launch of the agency's flagship Nancy Grace Roman Space Telescope. NASA and SpaceX are targeting 7:26 Eastern tomorrow, August 30th, for this mission, which will be launching from Pad 39A atop a Falcon Heavy rocket. Now, joining us today is a panel of specialists who will be sharing more about this mission. First, Nicky Fox, Associate Administrator of the Science Mission Directorate at NASA headquarters. We're also joined by Lucas Paganini, Roman Telescope Program Executive at NASA headquarters. Jackie Townsend, Roman Telescope Project Manager, NASA Goddard. Denton Gibson, Launch Director of NASA's Launch Services Program at NASA Kennedy. Julianna Scheiman, Director of NASA Science Missions with SpaceX. And finally, Justin McReynolds, Launch Weather Officer, 45th Weather Squadron at the U.S. Space Force. So we'll open with brief remarks from each of our subject matter experts, and then we'll take questions from media here in the room as well as those calling in. If you are joining us over the phone, please hit *1 to get in line. So without further ado, Dr. Fox, I will turn it over to you.
Thank you so much. I think you can tell in the room, everyone is really excited about this launch. And why? Because the Nancy Grace Space Telescope will blow your mind. It is the size of a tour bus, and it weighs the same as a T-Rex. So I'll just give you a moment to think about that. Right. It will also be the most stable telescope that we've ever flown, and the best cutting-edge coronagraph instrument. Roman's large field of view and fast survey speeds will reveal untold cosmic objects while shining a light on dark energy and dark matter. During its mission, Roman will discover tens of thousands of new planets, billions of galaxies, thousands of supernovae, and tens of billions of stars. And it will do all of that at a speed about 1,000 times that of Hubble. It also has a field of view 100 times larger than Hubble. So to put into context, what Roman can do in a month would take Hubble a century. Just one day of observing our universe, Roman will downlink 1.4 terabytes of data. That is an entire gaming system hard drive in one day. And that's a staggering amount of data. And if you think about that amount of data every day for the next 5 years, that would create a hypothetical stack of science papers that would reach beyond the moon. Roman's data will help bring us closer than ever to answering humanity's most profound questions, like how does the universe work? What is the universe made of? Are there other solar systems like ours? And are we alone in the universe? To put it into perspective, it will be as if Hubble and James Webb kind of peered through a keyhole at the universe, while Nancy Grace Roman will kick the door down. But Roman isn't just doing Hubble and Webb science faster, it's doing fundamentally different science that could not be done by either observatory. Together, these three flagship telescopes will combine their observations to give us a more complete picture of our cosmos. and our place in it. With Roman, we'll study galaxies across cosmic time, from the present back to when the universe was just 500 million years old. That's about 4% of its current age. And that's important as NASA leads the world in the search for life in the universe. And by understanding our universe's history, we can better understand how our planet formed and how life exists here on Earth. Roman will photograph worlds, dusty disks, and nearby stars in visible light to help see the giant worlds that are older, colder, and in closer orbits than the hot young Jupiters that we've previously imaged with other telescopes. Roman is kind of like a Swiss Army telescope, if you will, and it will bring us into a new era of space discovery, as well as re-examine the endless sky as we know it, and unlock the foundation for our future flagship missions that will take advantage of this incredible technology and the journey that we've gone on to allow us to search for habitable worlds in the future. One example, of course, for that is the Habitable Worlds Observatory, and that will use Roman's unprecedented coronagraph technology to image Earth-like planets around stars like our sun and study them for signatures of life. Roman will be blocking out the sun to see atmospheres around older, smaller, colder planets than ever before, paving the way for us to do more and more to find Earth-like planets. Roman is the culmination of a 20-year collaboration across the world. I could not be more proud of this Roman team. We are 9 months ahead of schedule and on budget, which is amazing, and it is a credit to this team that we are here today. Space is not for the faint of heart, and the Roman team exemplifies taking big risks for even bigger successes. Congratulations to everyone who has been part of Roman's journey to launch tomorrow. I can't wait, for one, to see the incredible images, probably around the holidays this year. And with that, I'm going to hand over to Lucas with the words, "Go Roman."
Thank you, Nikki. It's incredibly exciting to be here with Roman, ready to launch in the next few hours. This moment is the culmination of years of work, dedication, and innovation by an extraordinary team. And as you heard from Nikki, Roman is going to give us an unprecedented view of the universe. But what I want to highlight is what this team has accomplished to get us here. Roman brought together people from across NASA, industry, academia, and our international partners. Thousands of people across the country and around the world have contributed to this mission. And to arrive at this moment on budget and ahead of schedule is an incredible accomplishment. The performance of this team has been truly remarkable. Roman also demonstrates how missions like these help maintain U.S. leadership in science and technology, while advancing capabilities that will enable the next generation of space exploration and discovery. Roman is also advancing new technologies, from its state-of-the-art detector to its coronagraph, that will enable future missions and help advance NASA's continued search for life beyond Earth. So I'm incredibly proud of this team, and I'm grateful to everyone who brought us to this moment. And now to tell you more about the observatory that is going to be flying in a few hours, I pass it over to Jackie Townsend.
Good morning, everybody. Am I on? Can you guys hear me? Oh, good. Sorry. I did not prepare remarks today because I decided to speak from the heart, and I'm excited to say there are some words there, which is really good. I am excited and proud and humbled to be here today representing the incomparable Roman Space Telescope team. I wish we could all give them a standing ovation. As Lucas pointed out, it was literally thousands of people who made amazing, perfect, and wonderful decisions day after day, shift after shift for more than a decade. To go from where we started with a gleam in someone's eye with the acronym W first to the Nancy Grace Roman Space Telescope. And I've reported in countless briefings in the last week and a half that Roman is ready. The observatory is ready. The ground system is ready. The team is ready, trained, 1,100 hours of simulations, and just getting everything completely right. And maybe what I'm even more proud of is the science community is ready, because Roman belongs to the science community in ways at large, in ways that only a few flagships have in the past. And that is an amazing accomplishment. So with that, let me just also echo Nicky and say, go Roman, and go Roman science. It's going to be amazing. And with that, I'll hand it over to Denton, our launch director.
Good morning, everyone. I'm excited and humbled to be here to be representing the NASA Launch Services Program. And as Jackie said, I'm the launch director for the NASA launch director for the Roman Space Telescope mission. I can say, representing Launch Services Program, we've been launching NASA science missions on commercial launch vehicles since 1998, and Roman will be our 118th mission. And I can say honestly that in all that time, I have never seen such a smooth launch campaign, and be able to launch a science mission of this magnitude months ahead of schedule. And that's truly a testament of how well the Roman Space Telescope team has done developing and integrating this spacecraft, this monumental spacecraft. So it's definitely an honor to be able to launch this for them. And in that long history, we've had 15 missions with SpaceX now, and so we've continued to forge that great partnership we've had. And I'd just like to take a minute to thank all of the organizations that helped us make this launch campaign as smooth as it. Of course, the NASA team, SpaceX, and our friends at the U.S. Space Launch Delta 45 to getting us to this point. So last week, we completed our mission dress rehearsal, which is a simulated countdown where we really exercise the team, working through communication and working through anomalies to make sure that we're ready for the big day tomorrow. Last week, we also completed our flight readiness review. And just yesterday, we completed both the Space Launch Delta 45 launch readiness review as well as the joint NASA SpaceX launch readiness review, where leadership from all three organizations committed to launch tomorrow morning. And with that, I would like to play the video that we have there for you. All right, this is Roman arriving on the barge, and they kind of sped it up there, but June 21st. And this is them bringing it into the payload processing facility that we have here at Kennedy Space Center. And there you see them unpacking it, and you could see it breaking over, rotating into vertical. And there you see how massive Roman is in that payload fairing. It takes up almost the entire Falcon payload fairing. And there it is encapsulated, and that's transporting to the hangar at 39A. You can see it happened overnight, and that occurred August 24th. And then you got a good shot. This is a representative shot. This is not an actual video, but it's a representative shot of the Falcon Heavy in the hangar there. A good shot. And then, of course, we mated the encapsulated assembly to the launch vehicle on August 27th. And again, this is another representative shot of what it looked like when we rolled out late last night and in the wee hours of the morning. And we're going to give you a quick treat preview. We're going to cut to a live shot shortly after this, and you can actually see what it looks like sitting there on the launch pad. So if all goes well and weather permitting, about 6:25 tomorrow morning, we will poll the team to commit to propellant loading, where we will load the densified propellants onto the Falcon Heavy launch vehicle. And if everything goes as planned, at about 7:25 a.m. tomorrow morning, the launch vehicle will lift off, and we will get to see the Falcon Heavy lift off and put Roman on orbit where it belongs. And with that, I would just like to say Roman's ready, as you've heard. Falcon Heavy's ready, and the launch team is ready and excited for this epic mission. With that, I would like to turn it over to my partner in crime, Julianna Scheiman.
Thank you, Denton. Thank you. As Nicky said, you can feel the excitement for everyone here. I am super excited to be here today to talk to you about Falcon Heavy launching the Nancy Grace Roman Space Telescope. The data and discoveries from Roman will expand our understanding of the universe and inspire the next generation of scientists and engineers. And at SpaceX, we carry that spirit with us every day. We've been working with the NASA team, the NASA science teams, the NASA Launch Service Program teams for about 15 years to launch some amazing missions. Falcon Heavy has launched Psyche to a metal asteroid, Europa Clipper to Jupiter's icy moon, and we've launched GOES, which provides critical weather observations. And Roman continues that legacy of launching on Falcon Heavy. Super excited. I remember about 10 years ago when we first started talking with the Roman team, then WFIRST, about how we were going to fit that spacecraft in our fairing. We figured it out. But it's really a testament to the team, and every single person has poured over every single aspect of this mission, from the smallest thing to the biggest thing, every single thing. And I know I speak on behalf of everyone when I say we could not be more proud to be reaching this milestone, to be this close to launch, and be here today. So very exciting. Roman is just the beginning. We have a fleet of science missions coming up, including on Falcon Heavy, namely Dragonfly, which is launching to Saturn's moon Titan, and the Rosalind Franklin mission, which is a Mars mission, a Mars rover. And, that's just the beginning of the science that SpaceX enables. At SpaceX, we make science fiction reality. And that's what we're doing when we talk about our next generation vehicles like Starship and Starfall. Starship is a fully reusable launch vehicle and lander that can enable never before possible science missions landed on the moon and Mars. Imagine bringing your terrestrial lab to another planet. Think about the order of magnitude of discoveries we can enable. And Starfall is our low-cost, affordable microgravity research platform that enables in-space manufacturing and recurring access to LEO to enable science research. So that's some exciting things we have cooking here at SpaceX. But focusing on Roman, very, very excited to be here. As you heard everyone say, we have gone through all of the various milestones. We've gone through every single check you can imagine. And everything is looking great on the rocket. We're tracking no issues. The vehicle's vertical. And I cannot wait for tomorrow morning. So over to the man of the hour, Justin, to talk to us about the weather.
Yes, good morning, everybody. My name is Justin McReynolds. I'm with Space Launch Delta 45, the launch weather officer for this mission. And there's always buzz about weather, especially at this time of year. So we'll start with some positive news first. This morning, the National Hurricane Center is observing 2 different area disturbances out in the Atlantic Basin. I'm happy to report that for at least our first few attempts here, those don't seem to pose any impact to us going forward. So good news at least there. Going back to home, we've had a bit of what's called an offshore pattern here, where we have our southwesterly winds that are pushing offshore, and we're getting this sort of turn back to onshore winds, so the southeasterly, east-southeasterly winds, which tends to kind of give us a bit of a wetter pattern in the mornings, which it could be good for us rolling out in the evenings, but unfortunately, we're looking at this morning instead for Roman. That being said, we also have a bit of a upper-level disturbance that's looking over Cuba, and that's giving us more moisture inflow and all of that. So as we go to our forecast for tomorrow, we are unfortunately looking at a probability of violation of 50%. So we're looking at 50% go when it comes to weather. And that just has to go with the idea of that we believe there's going to be some weather around. It's the question of, is the weather going to be over the pad or away from the pad? Our primary concern with this is, of course, the cumulus cloud rule, and that is basically talking about the cumulus clouds that form. Like, we have big, puffy, fair weather clouds, and they can become showers, thunderstorms as they continue to grow. And depending on how high they are, that's how much we are worried about either natural or triggered lightning with how close it gets to the pad. So it's our big concern. Otherwise, as we're looking forward to our backup days being either Monday or Tuesday, we're still keeping this onshore flow, but we're losing that tropical disturbance that's out over Cuba. It's kind of pushing over to the west, and we're going to more of a normal probability of violation with a 30% chance or a 70% chance go. And that is what I have for the weather for now.
Thank you so much, Justin. I will say, I think it is incredibly special to spend the final hours ahead of launch with some people who have put so much of their heart and soul into this mission. The enthusiasm is just absolutely infectious. And so thank you guys so much for being here and for kind of being the pep rally that we need going into these last couple of hours before launch. Really, really special. So with that, we will turn it over to start taking some questions. If you are online, if you are on the phone joining us, if you can dial *1 to get in line, and we're actually going to start here in the room. So we'll start on we'll start with you.
Hi, thanks, Leah, and thank you all for taking the time with us today. Will Robinson-Smith with Spaceflight Now. Question for Denton and Julianna. The Falcon Heavy is flying with one new side booster, one that's flying for its third time. Can you explain why that configuration for the Falcon Heavy? And then just looking towards the future, it seems like the signs are pointing towards the eventual retirement and transition to Starship as that rocket continues to develop. You talk about the partnership between SpaceX and NASA for these exquisite science missions as Falcon becomes less available, or is there a push to keep Falcon 9 on to have it be an available rocket for NASA missions? Thank you.
You want to take the first part?
Whichever you'd like.
Okay. All right. So in terms of the Falcon Heavy configuration, why one has used and the other two new? For such an exquisite mission, there's very stringent mission assurance criteria that we have for our missions. And those were the boosters that actually met our criteria in terms of reliability, in terms of any risk or concerns that we may have. And I'm talking NASA LSP that I have. So we made sure that we do a pedigree review, ensure that the boosters are tested right, has the correct qualified service life, et cetera. And so we go through that, and those are the 3 boosters that our team were able to get comfortable with for this mission.
Yeah, just to expand on that a little bit. I mean, to step back, how cool is it that we're living in a world with rockets where we have a fleet of potential available boosters with which one can choose from, and we're, what would I like? Oh, that one sounds good. Yeah. So it's an amazing reality that we live in. I also wanted to point out that the side booster that has flown before did fly on a NASA mission. It flew GOES, which is pretty fun too. But as Denton said, we partner to make sure that the hardware we're flying meets all of the NASA criteria, and I fully expect a lot of this hardware to fly again and again, potentially for NASA or other customers, including our upcoming Space Force launch that's after the Roman Space Telescope mission. We'll fly those same side boosters. The other part of your question was essentially how SpaceX is working with NASA on science missions. And one of the things that I came to SpaceX to do was to enable science, and that's one of the things I'm super excited about that we've been able to do as a team. It's been really amazing to see how when I started at SpaceX, just in that period of time to switch to having a reusable rocket, and how that lowered the cost of access to space, which in turn changed the way the NASA science teams contemplate new missions. And we're already living in this universe where there's a proliferation of distinct science missions. It's really been amazing. And I believe the next generation of that is available with Starship. I mean, I touched on it lightly in my remarks, but when you think about such a paradigm shift of the amount of performance Starship has, and like I said, the concept of being able to take what would nominally be a terrestrial lab and put it on the moon and put it on Mars, it's definitely a different way of doing science, but I think it's really an empowering and amazing way to do science. So I know we've been working really closely with the science teams to come up with that class of mission, those amazing missions, and we'll continue to do so. Pretty fun.
Okay, we will right here, and then we'll go over here to the side in the orange hat.
I want to come back to the weather situation. We've had the flow pushing most of the storms inland, and now you're telling us that's going to change?
Sure. Yeah, we've been having, I guess that sort of onshore, the offshore flow that we were getting before was kind of pinning it on the Cape. Our onshore flow that we're switching to indeed does push the storms inland in the afternoon and evening hours when we start to get that sea breeze percolating. But when it comes to the early morning time, we start to worry about showers forming along the Gulf Stream and then pushing onshore, basically ahead of the sea breeze formation that we see usually around the afternoon hours. So it's uniquely a morning problem, unfortunately.
So you're saying 50% chance of launch. What are the criteria to bring the maybe up to 70% chance? What would that be like?
Hey, there you go. Well, funny enough, we do have that, we do bring it up to that 70% chance on the backup days, and that really is just because we lose that sort of upper level circulation above that's adding to the moisture and it makes it easier for the storm to be unstable and to grow and to exist in that sort of position. So if we were to lose that sort of feature, then we would find that 70% with that wind flow.
Great. We'll go over to this side of the room right here.
My question is for Dr. Fox. With the ability to download 1.4 terabytes of data on a daily basis and the distribution of so many teams around the world having access to that information, are you planning to address specific areas for focus for those teams? Like, we would like you to focus on this particular area for just to maximize the chances of finding amazing stuff. Thank you.
Yes, so that's a great question. Obviously, we have teams that are embedded in the Roman team. They've been working. They're the ones who sort of decided what the great science we want to do is, and those teams will be focused on particular areas. But really, for us, it is about embracing the open data policy that we have at NASA. As you heard, if you listened to the science briefing before, there's no proprietary time. So the high school students will get this as the same time as a Nobel Prize-winning scientist study at a prestigious university. And that's what makes Roman such a special telescope and such a special asset. But we also encourage, because we provide the ability to do the work in the cloud. So we provide tools, we provide it to really make it not just accessible, because I can give you data, but if I don't make it usable, it's not helpful. And so there's an area, you can actually form a team and share products and things through the cloud. And so this is really about a new way of making our science really available, accessible, and actually promoting that collaborative spirit. So if somebody is really interested in exoplanets, or they're interested in measuring the ancient universe, you can actually find like-minded people and work there on the cloud together.
Thanks. Fantastic. For the next question, we'll go to the phone. We have Stephen Clark with Ars Technica.
Hi, good morning. Ars Technica. Problem for as a on board. First,
We're going to take a question from the room, and then we'll go back to you, Stephen. Right up here, please.
Hi, Hagen Warren with NASA Spaceflight. I think this one will be for Jackie. Immediately following separation, what will Roman teams be looking for on the telescope? Will they be attempting to immediately establish communications and then go into deployments? If you remember, Webb had a very complex deployment sequence immediately following deployment from its rocket. So I was just wondering if we'd see something similar, if you'll immediately start deploying the solar array sunshade, or if you'll hold off on that and just start immediately beginning on working to get the telescope online. Thank you.
So our first opportunity to sync in S-band happens when fairing separation, which is less than 5 minutes after launch. But then, as you indicated, about 30 minutes after launch, when we separate from the rocket and we're on our own, that's the second opportunity where we attempt to sync up, and that is where we do our sun synchronization, so that we know our attitude and it's in control. And then just before an hour in is when we begin our deployments of our solar arrays and the lower instrument sun shields. And about an hour and 8 minutes in, we expect to be power positive.
Okay, we'll take one more in the room while we work to get Ars Technica back online. Jean, we'll go with you.
Oh, wait, sorry. Jean Wright, Space Up Close. Not really a question, just a comment. When I found out Nancy Grace, I'm going to tear up. When I found Nancy Grace was named as would be our first woman being named for a telescope, I had to do my research on her. And it was just amazing to me. From the age of 11, when she started her own astronomy club with fellow students, and she was discouraged from her desire to study astronomy, a career that was traditionally reserved for men. And as an older woman, I too remember fiercely wanting a career that was non-traditional, but not achievable for me at the time. Nancy Grace Roman did not wait for science to make room for her. And being NASA's first chief astronomer, laying essential groundwork for Hubble, she advocated for women in science. She helped build the future of space science, and now a telescope carrying her name will open an even wider view to the universe. And for younger women, I think she's going to great encouragement for this. So thank you all. Sorry, it's just emotional for me to see that I never was encouraged. I'll be 71 in October. We never were encouraged at my age to do anything like this. So it's amazing to me to see the women on the team. We have a telescope named for a woman, and I think it will encourage women, well, people all around, but especially young girls, and I'm happy for that. So thank you for letting me do this. Thank you.
Okay, well, that's a hard one to follow, but we are going to try. We are going to try to get connected with Stephen again. Stephen, are you on the line with us?
Yeah, good morning. Can you hear me?
There we go. Sounds great. Go ahead, Stephen.
Great. Stephen Clark from Ars Technica. My question, I believe, is for Jackie Townsend. I noticed that Roman has a grapple fixture on board. I think it's the first NASA science mission to have that capability in more than 30 years, if my memory serves. So I'm wondering if Jackie can talk about, the decision to add that to the observatory, and what other changes or design decisions were made to potentially enable satellite servicing for Roman down the road. Thanks.
Yeah, when Roman was handed its approval to proceed and its cost cap, we were also handed a requirement to accommodate servicing. I happen to have worked the Hubble servicing missions for a long time, so I have the benefit of knowing that while people think of serviceability as it either is or it isn't, in fact, it's a graduated spectrum. And while Roman is nowhere near as serviceable as the Hubble Space Telescope was, we do have everything that's necessary to enable the rendezvous and capture and docking between a hypothetical servicer. That's the point of the grapple fixture. And then in 2020, when we were baselined, we were told that we would focus on refueling. So there is the blanketing around the fueling port has been designed specially so that it's easier for a robot to get in there if we needed to refuel. And in Roman's case, that's the only expendable, the mission expendable. So if somebody has a servicer available for us in the next 5 to 10 years, we would be able to be refueled out at Sun Earth L2.
Fantastic. We'll go right here, Josh. Go ahead, Jason. You can do it. Here we go. There we go.
Hi, Josh, dinnerspace.com. Can you talk a little bit about the significance of the orbital location that Roman is headed to? What is the additive nature of Lagrange Point 2 to its mission? And about 24 hours after launch, there's a mid-correction burn for the spacecraft. Can you talk about the importance of that and how that is contributing to reaching the Lagrange point?
Okay. So Sun Earth Lagrange is out past the orbit of the sun. I'm sorry. Out past the orbit of the moon, which means that the bright objects, the moon, the Earth, and the sun, are all on the same side of the observatory. And we actually orbit around that stable point, and that means that we have a wide open view of the sky that really exceeds anything in low Earth orbit like Hubble could achieve. So some of that speed that we have, the advantage that we have over Hubble, is because we're not in low Earth orbit. The Earth isn't blocking our view, so we're able to access the sky more frequently. And I already forgot the second part of your question. Oh, the mid-course correction burn, right? So we actually have 2 mid-course corrections planned. The first one is just after 1 day in. The second opportunity is 4 days in. Now, if we get a absolutely perfect tip-off from or release from the SpaceX rocket, we will have low enough deviations from the plan that first mid-course correction could be small, and we would not need the second mid-course correction. But of course, it's our fuel that we are expending in these mid-course corrections. So the better our send-off from SpaceX, the less fuel we expend getting into the perfect orbit out at Sun-Earth Lagrange, and then the more fuel we have to conduct science past our 5-year prime life.
Fantastic. As a reminder to those of you who are joining us over the phone, if you'd like to ask a question, you can dial *1 to get in line. We're going to go back to the room here for a question on this side, and then Ken, you'll be next.
Thank you. Irene Klotz with Aviation Week in Space Technology. It's either for Jackie or Julianna. What is the orbital inclination and altitude at payload deployment, and what is driving the launch windows?
Yeah, so the way to think about it is we are sending the Roman Space Telescope Observatory essentially to a very specific target. And so when you're thinking about a launch window, you can think about essentially that spot in space. The way I visualize it, at least, I think about it moving overhead. But if you want to go to a very specific spot, the amount of time you have to actually lift off and actually target the exact spot as it's moving, that's what limits the launch window. That's when we think about essentially an instantaneous launch window. So for Roman, it's about a 30-second launch window to largely just enable the COLA, a potential collision avoidance maneuver if needed. But it's essentially an instantaneous launch window to meet the really tight orbit injection requirements. The way we often define the orbit parameters for a mission like this is usually in the terms of C3, so kilometers squared per second squared, essentially like escape energy. But when you're thinking about it in a more colloquial sense, just think about it a little bit of like an apogee over 1 million miles away. 1 million kilometers away. And if you want the very specific orbit, I can follow up with you after. But it's basically pretty far away. That's why you need a Falcon Heavy. It's pretty heavy, pretty far away. Is that anything you want to add?
You good?
Okay, Ken.
Hi, Ked Kramer, Space Up Close. Thanks again for doing this, and good luck tomorrow. My question for Nicky. First, congratulations on your award recently. And I'm also pleased to see so many women involved at NASA and at SpaceX, too. It's fantastic. I want to ask you to look again in the future a little bit. You mentioned the Habitable Worlds Observatory. Can you tell us a little bit about the status? Is that even an approved mission right now? What's the kind of like science you would do? How big would it be? Would it need to launch on a Starship? Maybe you can talk about that, too. Thank you.
Yes, so we're very happy. The technology development has been very well supported. And so what we are doing, we sort of, you think about lessons learned from missions before. We know that the Habitable Worlds Observatory is going to, Roman is basically the first milestone for the Habitable Worlds Observatory when that coronagraph gets on to orbit and starts taking data, proves the technology. That is, for me, is box number 1 of Habitable Worlds Observatory. But there will be a lot of design that needs to go in. The Roman Space Telescope is a very, very, very stable telescope. Habitable Worlds will need to be even more stable to be able to do what it wants to do. It will be our first life detection mission, so we're very excited about the fact that it is going to look for habitable worlds. And so right now we are concentrating very hard on getting all of the technology developments done. We don't want to start a mission and then realize, we have to do we should have done this. So we're doing the should have dones now. We have great partnerships with our industry, industry astrophysics specialists. As always, with every single astrophysics mission, we push industry to new levels because we don't want to do what we did yesterday. We want to do what we want to do tomorrow. And so every single time we do these, we push the capabilities of industry, particularly in like adaptive optics, precision optics, precision platforms, will have to be all next generation. And so we're putting a lot of focus on getting all of that ready so that when we say we're going to go, it will be like Roman, and it will be ahead of schedule and on budget, she said. So there you go. Probably need to keep the Roman team, maybe, but Jackie's not busy after 100 days, so she told me. But really, seriously, it is putting together a team as good as the Roman team, and having our industry partners with us to be able to really do what only NASA can do.
And do you need Starship for that?
We would be discussing. We certainly will need. Julianna noted, or maybe Lucas, that we've filled the fairing, and so we would definitely need a big fairing to be able to do that. I can't comment on what would be underneath the fairing, but I can tell you that we need a big fairing.
Okay, we'll go back to the room right here.
Thank you. Sawyer Rosenstein, NASASpaceflight.com. This is for Denton and/or Julianna. I was wondering if you can tell me which boosters are the core stage, which is the +Y and the -Y you've got flying on this one, the ones that you trust so much. And also wondering if you have the T0 to the second. I know it's like a 30-second window, but to the second for this attempt, and if we end up on the wrong side of 50%, what it would be for tomorrow. Thanks. Or the day after.
All right. So, yeah, so first of all, to the second would be 49 seconds. And in terms of tomorrow, it would shift by a few minutes. Excuse me, if we end up on Monday, it would shift about a couple of minutes in terms of the T0. And which one is plus versus my? I can't recall off the top of my head, to be honest with you.
I'll find it out after. I'm happy to give it to
Yeah.
you.
But you have the numbers at least?
Yeah, I'll pull it up after so you know exactly which one's which.
Great, thank you.
We'll go right here.
Hi everyone, Priscilla Mugwa for Clarity Press. Congratulations, first of all. My question is, how will NASA make sure Romans are accessible, that not only in the major institution, but also researcher and student in places like Africa, let's say Congo, and other underrepresented region? So
was your question, how will we make sure that it is available? Literally, by making the data complete. The portals are open, or they will be the moment the data starts flowing. There are tools. There will be tutorials. If you can go to nasa.gov/Roman, start reading about it now, start learning about the different types of studies and the different types of science that we're focusing on. That is all available right now. There are a lot of great outreach programs that we have. We have a citizen science program that you can get involved in. So really, this is about ensuring that, again, the data are not just accessible, but they are usable with, with that sort of advice and guidance beneath it. I will also say we do have a really great open science training that you can do. It is free at NASA that, again, will get people ready and more comfortable with being able to use our data. We can certainly work with other space agencies in the region and see how we could maybe help support that.
Thank you. Next question will go right here.
Lucas Paganini. How do you feel as a only South American representative in this project?
That's a good question. Thank you. I was born in Mendoza, Argentina. I couldn't even imagine as a kid being seated here at Kennedy. I still believe this is a dream, but even then, what's incredible has been to work with this amazing team and to learn from the way they build this mission, how they work on their schedules, how they can overcome. We went through a pandemic, we went through a shutdown, the longest in U.S. history. So there's a lot of lessons learned, and I'm sure those lessons learned will be applied to the future great observatories that NASA is going to be building.
Okay, I think we have time for a couple more questions, so we'll. Oh, sorry. Yeah, absolutely.
The plus Y side booster is 1104, the center core is 1105, and 1072-3 is minus Y.
Awesome, thank you.
Of course.
Love a woman with numbers. Okay, we'll take a few more questions. We'll go right here, and then Manny, we'll go to you next.
Thank you. Jackie Goddard for the Times of London. For Nicky, you've launched some pretty cool stuff at NASA to date, but can you talk about how where this ranks in terms of engineering feats? This is an observatory that was once thought impossible. So can you just expand a little on the complexity and the sensitivity and why something like this has been such an elusive target till now?
Yeah, I mean, it gets down to the fact that at NASA Science, we always push the boundaries. And so everything we do is doing something that we couldn't do or we didn't do before. Every telescope that we launch, we do the lessons learned, we take the technology that was created for a previous mission, we make it better, and we push forward to do this. I said before, I'm going to even say it now officially, that I have not been as excited about a science mission launch since Parker Solar Probe. So that's a pretty big one for me. And when I came onto the base, I mean, again, it's an electric atmosphere here at Kennedy, and everyone is ready for this launch. And, we know that this is going to revolutionize our understanding of the universe. And when you hear the scientists talk about what they're going to learn from this mission, how long they've waited to answer these questions, the fact that Nancy Grace Roman postulated how great it would be to actually launch a telescope into space and study stars and planets, and kind of paved the way for what we do now. In the science briefing, if you haven't had a chance to watch it, please do. Julie talked about just the fact that we have a model of the universe, and with the data we've been taking with the other telescopes, it's showing that the model isn't quite correct. And, that we know that when we launch this mission, we will have an actual model of the universe that not just for a single moment, but something for years that we can study how it's changing. And so to say we're going to revolutionize our understanding of the universe is not, just like a publicity statement. It will. And that, we will start proving the textbooks or rewriting the textbooks within months. Yes, it's 5 years to be able to do everything that we want to do, but we are going to be looking, making the first direct measurements of exoplanets around distant stars. We are going to be measuring dark energy and dark matter, and that's like measuring the fabric of the universe and the energy that powers it. And we've never been able to do that in the way that Roman is going to do it. We'll look at swaths of the sky that we've never looked at before. You'd think Hubble has done this incredible science. It's looked everywhere. It's looked at these amazing things. But there's so much of the sky that we haven't ever looked at. And that's what Nancy Grace Roman's going to do for us. Go, Roman.
Okay, Manny, we'll take a question from you.
Thank you. Manuel Masanti with Exploración Espacial. A question for Nicky or Lucas. We know that the telescope will take 100 days to reach L2 point. We know what is going to happen after the few hours after deployment. Can you briefly describe those 100 days? From the previous briefing, we know that some instruments are going to be turned on and some science begin.
So we have a 90-day commissioning plan. The first 10 days or so is, as is typical, is just outgassing, letting the deployment settle out, getting power positive, getting the temperatures to where they're going to be as we're on our big cruise. And then the next 30 days or so is commissioning the spacecraft, making sure that all of the kind of infrastructure parts of the bird are doing their job properly. And that is the period of time where we will begin powering on the instruments, but not actually taking measurements with it, not doing science with it. It really is making sure that the instruments are working as designed. They survived all the various bumpy ride elements from the fairing all the way out to up into orbit. And then the second 45 days of that 90-day commissioning is what we call science commissioning. So that's when we start tuning the optics. That's where we start getting it into shape. We'll be doing some calibration and validation activities with real observations of real stars to make sure that what we did on the ground maps as perfectly as we expect up into on orbit, so that we are ready at the end of those 90 days to just power into our early science operations.
Fantastic. We this time we'll go to the phone. We have a Katrina Miller with the New York Times Online. Katrina?
Hi, thank you so much. This question is just for anyone who wants to answer. Nicky already kind of answered it, but I'm just curious how you all are feeling leading up to the launch. Is there more nerves or excitement?
100% excitement, powered by dark energy.
Whatever that is.
I will say that it is a calmness around this team and around this launch. Obviously we're worried about the weather, but please, think good weather vibes for us tomorrow morning. But it is a calm. The team's hit every milestone. They've hit them ahead of schedule. It really just is excitement. A little bit. I know a lot of the team is a little bit of disbelief, just because when you've put your heart and soul into all of this, and then suddenly it's here. And I would think as well, there's a little bit of sadness in the team, because we're not going to see that telescope again. And when you work on these missions, the telescope becomes part of your team. It may be a piece of technology, but it's to us, it's got a personality. And you see it, and you're used to seeing it, and then suddenly you're never going to see it again. It's going to go and do great things, but you're never going to see it again. So I think there's quite a lot of mixed emotions.
Yeah, I would say that definitely it's been a team that's been together for more than 10 years, even though we formalized this mission in 2016. But what is most exciting, I was, I'm excited for many reasons. The first one is that, we have had these questions about the universe for so many years, and we might be about to discover what the universe is made of. Like, it's something, it could be like obvious, like we should know what the universe is made of. Well, actually, we don't. So that's incredibly exciting, and knowing more about these planets beyond the solar system, try to understand our own solar system and how common those are in the galaxy. That's also incredible. But also, we're not here to talk about the observatory we're going to build. We're about to fly it, and that's incredible.
For me, I expected to be feeling kind of anxious and nervous and excited and all of those things. But actually, after we finished the launch readiness review, it was that calm kind of descended. So for me today, this moment right now, it feels like we're at the peak of an old-time wooden roller coaster, and we're in the front car, right? So we've been ratcheting up slowly over the last decade up that very tall hill, and we've peaked. And now we're just hanging and waiting for the weather gods to tell us that it's okay to go. So it's going to be great.
Yeah. And
Justin, I'm feeling a lot of vibes being
yeah. And I would say from the launch side of the house, we're honored that we've been entrusted to launch such a monumental spacecraft. So that's an honor. And it's exciting because this is what we live for. And because we know this is such a monumental spacecraft, we've worked very closely with SpaceX to do everything in our power to make sure that we get Roman on orbit safely and as accurately as possible.
Yeah, I said it already. It's beyond exciting to be here today. It's beyond exciting to be entrusted to do such an amazing mission and to have partnered with the team for so long. I will say, it feels every time you launch a rocket, it's an amazing experience. Every time, it never gets old. And yet, working with this team, we have a rhythm to it. We know each other. We know how we work, and that also brings forth a sense of calm. So we're ready. We're focused on the mission. Cannot wait for tomorrow morning.
It's been kind of incredible to just kind of hear the stories that come out of this team. I came really, we kind of get involved a little late in the process since weather is a little finicky. We have to wait for that short term, but it's been incredible to see everybody really just synergize and to hear the stories spanning so many years. I've been telling, all the folks that I know, I'm like, I can't believe they put me on this mission, and it's been just a joy, and I'm really hoping that we're able to deliver some good news for you guys, if not tomorrow in the coming days.
Fantastic. Okay, I think we have time for one more question. We'll go right back here to the back of the room.
I've got one quick question that as a journalist in Asia, we all have very incredible memory of going through Hubble's excavations during those period and 20, 30 years back. But what are the formidable challenges that Romans saw 10 years back? And what are the incredible memories as a team that you all overcame to sort of be part of this journey?
So for me personally, both the challenges and the most exciting moments are the ones where the team comes together like NASA does to work the problem and get to resolution. So as a project manager, for me, a lot of those problems that get worked and challenges that we have to overcome are more human than they are technical. But it's really that same toolbox that we all learned in engineering or science class about how you methodically break down a problem and figure out what tools you have to tackle it and what resources your team can bring to bear. So whether it was a cost cap before we even had a mission design or a detector that wasn't working in our last thermal vac test, right? This team just comes together and knocks it out of the park. It really is an honor to serve and to be counted among the Roman Space Telescope team, and that is true for all of our partners, the ones that are here on the table, the organizations they represent, ESA, our international partners, our industrial partners. It is amazing, and it is a testament to what we can do as humans when we decide that we're going to do it.
And I would just say from a scientific sort of piece, you mentioned Hubble. I remember gasping at seeing Hubble images when I was, young child, and maybe not a young child. Ooh, wish I was. Anyway, a student. But seeing those images of the universe and just literally gasping and wondering why. We designed Roman to tell us why.
Man, I don't know that there is a better way to end this news conference. Unfortunately, that is all the time that we have for questions today. Again, NASA and SpaceX are targeting tomorrow, 7:26 a.m. for the launch of the Nancy Grace Roman Space Telescope from Launch 39A right here at Kennedy Space Center, and the launch the launch coverage is set to begin at 6:20 a.m. For more information on this mission, if this tweaked your interest a little bit and now you need to know even more, please visit www.nasa.gov/Roman. Coming up here very quickly, NASA Administrator Jared Isaacman will be taking a final look at this mission on the pad before liftoff tomorrow. Starting, you'll see a series of several flybys by the pad today. NASA Administrator Jared Isaacman will be leading a formation of 3 F5s at about 11:45. For those of you who are joining us virtually, we invite you to stay on, watch for a little bit, hang out, and view that. And to those of you who are sitting in the room with us, we invite you to be dismissed, to go set up, and to see that in person. Thank you so much, and go Roman. Go Roman.